Hello everyone, how are you all doing? Welcome to today's class. So let's continue from where we left off. So before diving into the today's session, did anyone get the chance to practice the course we worked on Eclipse? So did you all practice with all the data types? Okay, now let's get started. So let's give me a quick rundown. Yesterday, we started by creating a Java project in Eclipse. Then we created a package inside the project. A package is a folder that we create inside the source folder. Okay, so like this one. So after creating a package, we create a class. After creating a class, we started writing and running our code inside. Now let's clear some confusion. When you start Eclipse, you first need to start a workspace. The workspace is a folder where all the projects and code files are stored. After selecting the workspace, we create a Java project. When a Java project is created, Eclipse automatically provides a GRE system library and an SRC folder. So the JRE system library contains all the predefined tools and functions required to run Java program. And the SFC or source code folder contains all the code files stored. Since different parts of the project need to be organized, we use package to store related code files. A package is a folder inside the SFC folder. It helps organize different part of a project so that code related to different features is stored separately. Now, inside a package, we create a class. The class is where we write our actual code. Without a class, we cannot write and execute our uh, code in Java. So, put it simply, workspace is used to store all projects. Java project is where our code is written. SRC stores all our code file, and a package organize different features, and class is where the actual code goes. Since we practiced data types yesterday, today we are continuing with Boolean. So Boolean is a primitive data type. Okay. So Java has two data types. Um, wait. So Java has two data types. One is primitive and the other one is non-primitive. In primitive data type, these are stored numerical values and take up memory in their own storage space. And in non-primitive data types, they include arrays, strings, objects, etc. So Boolean is a primitive data type that can store only two values. So for Boolean, that can store only true, false. Okay. So when a Boolean variable is created, a storage box is created in memory. Then the box is assigned a name, which is variable. Then the variable holds either true or false. So if we write suppose Boolean is raining equals false. So here a box is created and the variable name is raining, and the value stored inside it is false. So by default, a Boolean variable holds false unless assigned to true. So a Boolean is useful when working with conditions in Java. So here we can see that, excuse me. For example, if we write integer a equals 10, c equals 20, and print that a less than c, then it will give the output true because A is actually less than C. But if we write A equals 10 is equals 20 and write A greater than 6, it will return false. Okay. So after checking the condition, if they see that 5 is smaller than 10, it will write true on results, or otherwise it will give false. So Boolean values work with comparison creator like greater than, less than, greater than equal, less than equal, etc. Okay. So if a Boolean condition is incorrectly written, Eclipse will show a compile time error. Now we'll dive into Boolean in control structures like if-else loops, etc. So everyone please practice these examples and let's continue. Okay. Now let's talk about Boolean in Java. Boolean is a data type that is used for conditions. It stores true or false values based on the conditions. Okay, which I have shown like a greater than C or say a less than C, etc. So Boolean only works for conditions and can hold true or false values. If you don't assign a value to a Boolean variable, what does it store? The default value of Boolean is false. When you write true, it replaces the default false and creates a new value. To see this in action, you need to run the code and the console will show the results. However, can you store numbers in a Boolean variables? No, they doesn't accept any numbers. They only store true or false. Now let's move on to the character data type. So what a character data type is a C, we write it by char, which is a character. So it stores a single digit. Okay. So it stores one digit, like one letter, one symbol, etc. So suppose the character here, it is the default value 0. Then if we put one character or one digit or one quotation, sorry, quotation, okay. So character must be enclosed in single quotation. So the default value of character is null character or 0. Can we store multiple characters in char? No, it only holds one character. Okay. Now Java has different types of numbers. We already know Boolean and characters. Now let's explore numerical data types. Okay. So here are some example of a numerical data type. So byte is one byte. It ranges from minus 128 to 127. Short is like 2 bytes. Then integer is 4 bytes. Then data types long is 8 byte. Float is 4 byte and double is 8 byte. Okay. So byte is smaller than integer. Byte can store values from 128 to 127. While integer can store only can store a much larger range. So from here we can see that From this code, we can see that Boolean is true, then character suppose is G, byte is 120, short is 6000, integer is 500, then double is 666.66, then long is 6000, and float is 616. Okay, so the long values must end with L, otherwise Java assumes it's an integer. And float values must end with F, otherwise Java assumes it's a double. Okay, so float is like decimal, which is point, which which contains point. Then double is like same, it says same as float, but it contains larger number. Okay. Now, how Java reads and executes code? Java reads the code in usually two ways. Okay. So Java reads usually two ways, top to bottom and left to right. Okay. For example, like integer x equals 10, which where integer int identifies as integer, x is the variable name, and 10 is the value assigned. The Java virtual machine doesn't process everything at once. It reads step by step. Okay. Now, when you write Java code, all the data stored in the memory, but you can see it unless you print it. So after you print the values, you can see that it prints all the value results like 6,000, 5,000, 6,000, 6.6, 666.666. All of these values. So primitive data types are predefined by Java and store simple values. Non-primitive data types are more powerful, but not predefined, and can store complex data. Now let's learn about one particular non-primitive data type, string. Okay, string is widely used in Java. A string always starts with a capital letter and it acts like a primitive data type, but it is actually non-primitive. Okay, so suppose we usually write integer equals 5,000, integer c equals 500. It's an integer. So the primitive data type, there is it's a stack, and these are the primitive data type, and these are non-primitive, where it contains integer or other variables. So suppose it is a primitive data type hello world. For example, string s1 equal hello world. So is string a primitive or non-primitive data type? It is a non-primitive data type. So now what does a string always start with? It always starts with a capital letter and we need double quotation. So Java has usually two memory compartments. One is stack and the other one is heap. Okay. So here you can see that the stack one contains all the primitive data type and the heap has all the non-primitive data type. So the stack contains integer, character, etc., and the heap contains objects, strings, etc. So suppose we can write the string s1 equals hello world, string s2 equals hello world. Now the s1 box is created in the heap memory, which is string constant. Now, if you write integer I equals 5000, j equals 5000, for integers, s operator box is created for each variable, which is int. But for a string, like string s2 hello world, there won't be another box because strings are immutable. So why strings are immutable? Once string is created, its value doesn't change. Java reuses existing values instead of creating new ones. If Java created a new box every time a string was declared, memory would be consumed unnecessarily. For example, if 100 strings had to be stored, each would take up extra space in the memories. This would slow down the system, just like having too many apps open on a laptop with a slow SSD. Okay. Now let's create another class and explore concatenation. So we create another class, name it concatenation. Now suppose we write string plus 10 plus 20. Uh, string 10 plus 20. String 1020. Or we can use calculation plus string. Then it equals 70 plus string. So here is 30 plus 40 is first calculated. So it results in 70 string. Okay. But what happens if parentheses are involved? So the brackets are computed first. For example, string plus 30 plus 3, where it will result string 303, not string 33. Suppose here we can see that three kinds of output. One is uh, one is 50 hello world, another one is hello 40 world, and another one is hello 50 world. Okay, so here it is happening because the placement of the string and the parentheses. So the Java virtual machine will calculate the things which is under the parenthesis first, then the outside later. Okay. So let's understand how an exact statement in Java using system.out.print. So system.out.print go into the value of I is let me show you, okay. So the value of I7. So here the value of I is string enclosed in a double quotation mark, and the plus I7 is concatenation, which joins the string with the variable I7. So the result printed value in the console will be the value of I7 is 14. Sorry, 40. Okay. So here integer I7 equals 40, which is the variable storing 40. Then in string S6 equals hello world. Sorry, string S6 equals uh, uh, hi brother. So it will print the hi brother later. Now let's use some mathematical operation in Java. First, we create a class in Java. So what are the mathematical equation? So after creating a class is addition minus is subtraction, then comes multiplication, then division, then remainder. So suppose let's run addition where we are running. So you can see here two types of addition. One is if you write the addition of A and J is plus A plus J. So it will add those two, 6060, which is 6060. But if you write A plus J outside of parentheses, it will consider it as two separate numbers and would merge them side by side, which shows here, which is 6000 and another 60. So also, if you write uh, just plus addition instead of A plus I plus J, it will also show the addition result, which is 6060. Okay. Also, there is another way. If you write system.println S1 plus addition, okay. So string S1 equals the addition of A and J. It will print the addition of A and J. Okay. Now Let's try subtraction in Java. Okay. After addition, then comes subtraction. So for subtraction, you can write uh, system.println subtraction of nj is exactly like addition, just you can use minus instead of plus and subtraction instead of addition. It will show the result. Okay, just the sign change. Then for multiplication, you need to use the for this you need to write int multiplication equals a into j, a star j. So it will multiply the a and j, then write string st equals the multiplication of a and j equals. Then print the string and plus the multiplication. So it will multiply the value and show it here. Okay. So S3 means the string inside the string S3 and the multiplication means the result of the multiplication. Then for division, you can write division instead of multiplication, and you should write a slash j, which will which will divide a by j. Then you can again you can write the string and print the string plus the divisional result. It will show you the division. And for reminder, you can also same the system of uh, multiplication, division, remainder are all same. You just have to change the symbol. Here you change it by uh, percent. Okay, so it will show the result of the remainder. So these are all the arithmetic operations of today. Practice each of the arithmetic operation 5 times using different values. Then continue working on the test case and the defect report. And I will see you with more operations in the next class. Till then, thank you. Okay.